These notes are going over activity 4.8. We're talking about polyatomic ions. So polyatomic ions, if we kind of break down that word, poly means many, atomic means atoms. So these are ions that have multiple atoms that make them up. Okay, so for example, we have sulfate here. Okay, we have both sulfur and oxygen that are combined together, but the whole compound is actually an ion, and it becomes a charge of -2. Okay, so sometimes covalently bonded compounds have an overall charge, just like sulfate, and so because it has this charge, because it is an ion, it can bind to positive ions in the same way that simple atom ions are bound together, like what we did with ionic bonding before. So on the second page here, I kind of have all of your like cheat sheets on how to do polyatomic ions and figure out the chemical formula for each of the given compounds. Okay, so once again, use the crisscross method just because it is much simpler than having to do the Louis dot structure. But here we have our positive ion on this end, okay, are on the listed first, and then the negative ion listed second. And so we first write out the ions with their charges, and then we crisscross the ions, drop the charges, and then with this, an extra step is we're going to add parentheses if needed. Okay, and so the reason why we need parentheses, why it is important, is because if we were just to put the 2 next to the 4, first off, it would look like we had 42 oxygens. And then also, we need to make sure that this 2 basically is distributed to the potassium as well. Okay, so we're saying that this whole compound here, there are 2 of them. So we need to put the whole compound in parentheses. Okay, we don't put the whole thing in parentheses because we don't have an additional 2 of the calcium. We only have 2 of this compound. Okay, and then make sure that you reduce if need be. We have 3 and 2. We don't reduce here. Okay, and when you look at reducing, you're only reducing the numbers that you've added. You're not reducing any of the numbers inside of the parentheses. Okay. Here I have a list of the common ions. So we have a common cation, ammonium, okay, cation meaning that it's positive, it's lost an electron. And then here are common polyatomic anions. So they're going to have a negative charge. They're going to want to take electrons here. Okay. I also put down here just the common, just singular atom names. So like if we have oxygen, it would be oxide, nitrogen would be nitride. So that those were terms that we used for previous ionic bonding and naming. And then just as a note as well, if there's a Roman numeral next to the name of a transition metal, that's telling us the oxidation number of that metal, and it will be a positive one. So if we have gold 2, it's going to mean that our ion is going to be Au 2 plus or plus 2. Okay, and then a nickel 1, it would mean that we would have the Ni plus 1. Okay, I could have just put a plus there. So moving on to examples, if we have ammonium nitride, I first have to write out the ions, so ammonium and nitride. So if I find ammonium, here is the ion, and then nitride is here. Okay, so you might have to spend a little time. Make sure that you don't get thrown off and accidentally do like nitrite or nitrate, because that's going to give you a different answer. So nitride. So pay attention to the endings of the words to make sure that you're not mixing them up. Okay, so I'm going to have NH4 plus and then N3 minus, which is what I have here. When I crisscross these, Okay, I will have 3 NH4s and I will have 1 nitrogen. Okay, when I drop the charges, and then I'm going to drop the 1 because it's not necessary. I made sure to put in my parentheses here so that I know that I have 3 of my ammoniums. Okay, so it ends up being this chemical formula. Okay, for the next one, calcium hydroxide. So calcium is just the name of a atom on the periodic table, so I will just put in calcium. And so if I were to go look at a periodic table, I don't know, yeah, so here is calcium here. It's in the second column, so it has, or in column 2A, so it has 2 valence electrons. So here it's going to have an oxidation of +2. Okay, and then hydroxide, if I look, here is hydroxide, and it has a -1 as its oxidation number. Okay, so I wrote those out. When I go to crisscross, I'm going to have 1 calcium and 2 hydroxide compounds. So here I dropped the 1. I made sure to put in the parentheses so that I would note that I have 2 of the hydroxide compounds. Okay. For the last one, nickel 1 nitrite. Okay, so nickel is just a name on the periodic table, so I would just put the symbol for that, so Ni. Because it has the Roman numeral 1, I know that it's going to be a positive 1 ion. Okay, and then for nitrite, if I go back to my cheat sheet, I find nitrite, and it is NO2, and then it has a charge of -1. So I wrote down NO2 and then a -1 there. Okay, so whenever I crisscross, I have 1 of each. Okay, and so I'm just going to drop the 1s, and I ended up writing out the chemical formula as NiNO2. Okay, you'll notice I don't have parentheses. They're not needed because I only have 1 of the nitrate compound.